Hello and welcome everyone to the next stream of the Flying Fox. Today we'll be looking at how to implement collision detection. Although we won't be actually implementing it into the Flying Fox yet, we will discuss the collision detection techniques today. And once finished with that, we will go to the next live stream. We will implement these techniques. So, as you can see, here are our goals, exploring different strategies, as I said, and implementing a demo for the iterative and collision grid approaches. We won't be covering QuadTrees in this video, and our collision grid will be a bit of a naive approach. Next stream we would like to cover how to actually implement these. We'll see about that, but I will experiment, behind the scenes, and we'll see what we can do. So let's start with the first approach of implementing collision detection. This is just like having two nested for loops and checking if every collider you have in your entire list collides with every other collider you have. And obviously this is highly inefficient because let's say you have a collider on the top left of the screen and you want to check if it collides with something else. You then check everything, even if it's not even near that collider. I can let's see if I can. I'm just going to put this on. Let me show you with a little drawing, I'm just going to wait for the stream to catch up. Hopefully it does. So let's say you have a collider here and you want to test, does it collide with anything else? Now with the for loop approach, you are checking if this collider is colliding with this collider. Now obviously that's just, it's idiotic because it's not even close to each other. But this does have its merits, If you quickly want to create a demo and check if everything works, you can just implement this and forget about it. It works for quite a few objects, especially if you're going to do 2D game development. It's not that bad. I'll show you how, I think it was 500 objects it could handle without crashing. So other solutions is by storing our colliders in beta data structures. Now this is much easier said than done. One of these data structures we can use is a QuadTree, where we recursively create smaller collision areas, if I can say it like that. Another example is a collision grid. The collision grid is conceptually much easier because you just divide the actual screen and map into little sections and check the surrounding sections and the section itself, but we will get to that later. First, it's the QuadTree. This is just a normal data structure that you'd find somewhere at other places in computer science, where you just take your initial area and you divide it into smaller areas. And this sounds pretty good, but the problem is when you want to insert objects and you have to, when they're moving, you have to constantly insert and delete the objects and insert them into different sections. But we won't go too deep into this subject, and we'll move on to more naive approaches. This collision grid is the approach we'll be implementing into this video. So you just divide your map, you take your map width and your map height, and you divide it into small little cells. Now this is easy. You can insert, you can easily see by taking the position of a collider and dividing it by the cell size in which cell you should put it. So this will be what we'll be implementing in this video. Here are our limitations today. We won't be accounting for objects that are larger than the cell size. The colliders aren't aware in which cell they reside. This can possibly be an issue later on, and you have to call a move function or method through a grid instance. And it can be distasteful. Furthermore, it won't really return any useful information as of yet. It only gives us feedback to if it collided with something else. And let's get into, we just show the big limitation of our good old collision grid today. So let's say we have a cell size, this line, let's illustrate this better. Here's our cell. Just assume that all cells are this size. Now, if we have an object that's bigger than this, we have to put it into the cell, not only into this cell right here, we have to put it in the above cell and the right next cell. So this can be a bit tricky. It's not that bad, you can calculate this, but for today we won't be accounting for this case. However, we will be accounting for objects or at least smaller than or equal to the cell size. For example, an object like this, we will be checking if these two objects collide. So let's get to it. Just open VS Code. Okay, as with every VS Code project, you'll be starting by running the command .NET new mg desktop gl and let it create for us everything we need, and we will just check if it works. There we go. Okay, here's our basic project. Let's close that and set up our debugging. Okay, it hasn't detected yet which. There we go. Okay, now our debugger is set up, and I'll just open our project. I just want to open out the repository I already created. Just want to make sure I don't make many mistakes. Come on. Go. Okay. Let's start at the beginning. So first off, we will need a grid class and a cell class. The grid class will contain obviously a grid of all cells, and the cells will contain the actual list of colliders. But we don't actually have colliders yet, so we'll quickly create them. Since we want this to work in our future game, we won't be using the normal rectangle class. We will be using a rectangle F class. It's just a rectangle with floats. And this is not available in MonoGame itself. You can just add it to your project by running the following command: .NET add package MonoGame.extended, and we want the older version 3.7. There we go. Okay, let's start off creating our, not in there, come on VS Code. We want to create our collider. So, we just make this as a class. I think we can actually, because we don't have to pass it, just make this a struct, a rectangle collider. We won't be adding other colliders in this video as well. We're just sticking with this one. Now we can't inherit from rectangle F. Let me show you why. As you'll get an error saying it is, well, this is the wrong rectangle F. You get your error saying it is concealed type. Okay, that's when we make this a class. Sorry. There you go. Now you can probably just, get the source code from GitHub of MonoGame.extended, but we're not going to do that. We will just use composition instead of inheritance. So we'll define a public rectangle f that we'll use. This would be the actual underlying rectangle. Now we will access the x and y coordinates many times in this project, but we don't want to type the RectCollider.rect.x. I mean, that's silly. Why would we want to do that? We're just gonna define a variable float x, and when we get this variable, we're just gonna use a little lambda function that returns the rect x, and when we want to set it, so we can just, outside the class, we can now say, if we define this, dot x equals 10. We want to be able to do that, so it will be a public get and set. So we're just going to say for our lambda function, rect.x is equal to the value we pass in. Furthermore, we want to do this for y as well, so we can actually just copy, paste. Just remember to change your values. So rect y and rect y. Now in our project we want to see when are these rectangles colliding with each other. To do this, we will have a little Boolean variable we call is colliding. We will use this variable to draw the rectangle as red instead of white. Let's initialize the entire class. We need a constructor for that. And we want, of course, to pass in where we want our rectangle and how big we want it. And this is just normal boilerplate code, so we can just say rect equals new rectangle f, x, y, small. Why is this taking the big y and big x off? Just fix it. I don't know why VS Code is correcting me to that. It's not supposed to. There we go. And default, by default, we need to say the collider is not colliding yet. Now we will just draw this quickly. We will pass this thing. We will pass in a reference to the sprite batch, which we will use to draw a rectangle. And since we are using MonoGame extended, this is easier just to say sprite batch dot full rectangle and our current rectangle. And of course it wants a color, yes. We'll by default make it white so we can see clearly. And if it's not colliding, it should be white, and if it's colliding, it should be red. Color red. There we go. And there's not anything really we want to update in this class, because we want it to stand still unless we want to move it through the grid. That will be the only thing we'll move in this collision grid demo is the player. We won't really be accounting for moving objects. I mean, you will see you can still make moving objects, but for now we'll just focus on moving a single object and checking if it collides with others. So we just want to say if it's not colliding with anything. Why is this not working? Here we go. If it's not colliding with anything, we just make it false. We aren't actually checking collision in this class. we will be checking this in the cells class if it's colliding with anything else. Or struct. We will make it a struct because we won't be passing references. There will be only one instance of grid, and that instance will reside in the game class. Okay. Let's see if there's any questions. Okay, no questions. So let's proceed, create our cell class. Okay, this would be a struct for cell, all previous reasons, and this is where we will put our list of all our colliders. We'll just go with colliders. We need to initialize that in our constructor. As you see, probably doesn't it doesn't even recognize that we should initialize it. I thought it would be yelling at us, reminding us of what we should do. Otherwise, if you don't do this part, you're going to get no exception. Anyway, so the basic functionality we want will be inserting into cells and deleting from the cells. Lastly, we also want updating the cells or updating colliders within cells. Let's start with our good old insert method. This is an easy method. I mean, you just say colliders.insert. Now, of course, you can use a different data structure instead of a list. Because a list, you have to search through an entire list to check if anything is colliding. If you can think of a better data structure, use that preferably. But for now, this is fine. So we'll just find a RectCollider. Let's call this collider. This is easy code, you can quickly write. Sorry, this is list doesn't have insert, it has add. Now if we want to remove a collider, we'll just call our delete method and we'll say not remove. So at least C# does actually check if it is the same object under the hood, so we don't really have too much here. Now we want to check if any of the colliders are colliding within the cell. So if we, let's go into Inkscape again, so I can illustrate this. Okay. Let's quickly create a grid for us. It won't be a perfect grid, but it's fine, it's good for illustration purposes. So there's our grid, and here are our colliders. So now, for every cell, we want to check if the colliders within that cell is colliding. So we're checking if this guy and this guy are colliding. Since we are using rectangle under the hood, it is easy because we can just say rectangle.intersects. That uses AAB collision and AABB. And you can just Google search it and find the video explaining that. But for the purpose of this video, again, not necessary to understand it, you just know what it does. It just checks if they're touching each other or if they're within each other. That's all. Okay, now let's do that. This will be within our update function. We won't be using game time in this update function. So, no need to have any parameters. This will be called every frame, and it will be called from the grid struct. So we will just go from the start of the list to the end of the list and check for every collider if it is colliding. Just want to see what, yeah. So we'll just go, this is almost exactly the same as the for loop method, but it's instead for every cell than the entire map. So of course we don't want to check if a collider is colliding with itself. So if the current index is, if the index I is equal to index j, that means we are at the current collider, and we won't be checking if it's colliding with itself, so we'll just continue to the next iteration. Now if the two colliders, the one at I and the one at j, are intersecting, we will set the variable is colliding to true. What's the problem here? And since we are only calling this the if it collides with another collider once, it will always be red. So we will just want to reset it to white if it's initially. So we'll just call our collider update function that we defined previously. Reset it to white, and then check, reset it to white, check for collisions. If it's colliding, set it to red, then next iteration, reset to white, check collisions again. Okay. Now, later on, we will also need to check for adjacent cells. Let me go back to my illustration. Let's copy this. Like that. And more or less like that. There we go. Okay. So if we have an object that's here in the middle, across different boundaries. Now obviously, if we only use, you'll see our algorithm only checks this little point right here. It doesn't actually check if it's crossing a boundary. So since we're assuming that every collider is smaller than the maximum cell size, then we can say, okay, so the maximum like collisions it can, or places where it can collide, if it's, let's say, like 20, so we'll make this the same size as the grid, is 9. So it can collide somewhere here, 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 here. You get the idea. So to check for that, we will be implementing a method where we pass in a collider and we check. So we pass in this little guy from another cell from within the grid struct. We pass in to our method, check collision, and we will check if this guy intersects with any of the other things in this cell. So when we have something where it's across cells, we will be checking, for example, if this is happening, this collision. So let's go back to our code. This is just a helper function, so it's not supposed to be too complicated. So check collision. Our RectCollider, we'll just call it rect A, and for each RectCollider, rect B in our current cell, for all the colliders in the current cell, check if they intersect with the other collider. You know what we can do if we, let's refactor this, as we'll be calling this a lot as well. So we can just create another lambda function. This will be bool intersects, and we'll say RectCollider other, let's just say rect B, and we'll define it as return, what is it? This is it rect.intersect rect b. Is this no rect b.rect? There we go. Now we don't even need to do this anymore, just for clarity, so this code is easier to read. So if it is intersecting, we know they are both intersecting each other, so we can say it is colliding is true for both of them. There we go. So we will be using this for rectangles or RectColliders within adjacent cells. Check, no questions. No, okay, so we're fine. Check if my mic is loud enough. Yes, okay. Now we move on further with this example. It's the same example. We will pass, we don't want to pass every single collider within a cell. We'll just pass a cell and we'll check if everything inside that cell is intersecting with anything outside that cell. So this will be our other method. I'll get void check cell division. And this will take in a cell. Let's call it cell A. And we will check if every rectangle collider in the colliders list. Now check if they are intersecting. So this is just, as I explained previously, checking if the adjacent cells are intersecting with each other. Lastly, we want to be able to see our colliders, so we won't be creating a separate class, a sprite class or something. We'll just, because this is just a demo, we'll be creating a draw function that just draws the actual RectCollider. So it's just passing the sprite batch to every collider we draw. So sprite batch, reference to sprite batch. So for each collider in colliders, so every collider inside the cell, draw that collider. There we go. That is our cell class. I see I misspelled this. This is not supposed to be cells, it's supposed to be cell. There we go. Okay, now we move on to our collection of cells. This will be our grid. So this is just a container for all the cells, because it's just easier to define methods within it and use them instead of writing everything in the game class. Let's get to it. Define it grid.cs. This will also be a struct since there will only be one instance and no need to pass references. So this is our cell size. We'll make it a constant and we'll define it as 20 in this example. Beware, for this naive approach, do not make the collider bigger, greater than cell size. Beware. Okay, so we want the number of cells in the X and the number of cells in the Y, which we'll just store in two private variables. This should be private, by the way. A private variable cells X and cells X and cells Y. And the data structure we'll use for this will also be a list, or actually a 2D array. So we'll just define that cells, private cells, yeah. Just remove this. Okay. Now when we call the initializer, the constructor for this grid, we will pass it a width and a height. This will be the map height and the map width. So we'll just define this public create int map width and int map height, and we will say the number of cells that it will contain is equal to the map width divided by the cell size. It's easy to explain again. Let's say that this part, I don't know if that highlights it correct nicely, this part is our width, so we'll just take this. If it's like 100 and we have a cell size of 10, we divide it into 10 little cells. Okay, and same with height. Cells y is equal to the map height divided by the cell size. So you also want to make sure, another warning is that map width and height are multiples of cell size. Otherwise you're gonna get half a cell, and that's a bit weird. We don't really want that. Can cause undefined behavior. I mean, if you get it right to implement it and it doesn't cause an issue, go for it, but not in this demo. Remember to initialize our array, and this will be size x of cells and size y of cells. Now we need to initialize every single instance inside the cells to a new cell. So we'll just go to the for loop. This is for x, the standard, this kind of, the standard line of code you almost use everywhere. You can even use this for, you know, double pointers. Okay, array of arrays. But we're not using pointers today because we're using C#. Okay, if you don't do this, you're also going to get like a null exception because cells is not initialized, so you can't call any function of cells. Okay, now we want to be able to insert a collider into our grid. So quite an easy function again. This is just public void insert. We'll just take the collider. You can also define one for into exactly the position you want. So this can be float. You can also define it like this, and y and collider. But we're just going to use a simple approach. It's just RectCollider, and we'll calculate the actual cell bounds inside the function. So we'll say I, now this is the x position in the array, is equal to int. So we'll be using the division. Otherwise, if you don't use this, you'll be you'll try and, sorry, I can just write this out and I'll explain it. So this is an int, this is an actual float because it's a rectangle f. If you aren't casting this to an int, it won't truncate the decimal values, and we can't store a float into an int. And of course, you can't have float array indexes in your array. You need int indexes. And this is our next one. Line y divided by cell size. I don't know if I need to explain this to anybody. I think you'll be fine. It makes sense. If you want an explanation, just ask. I don't even know how many people are watching, but Just ask if you need anything. See, okay, no questions. Okay, see, we just insert it in. Now we want to delete, be able to delete from our thread. Now this will be a little bit weirder, and it will become clear why we do this later on. So I'll just put myself a reminder here. Explain why we use indices. Okay. So we'll pass the RectCollider again. But now we'll pass the actual indices where we want to delete it from. So we'll go to that specific cell and we'll just delete this collider. I'll explain it in a moment. It will actually be, this is relevant to our move function. But it's going to be a while before we get there. Let me think, maybe I should just explain that first. Yeah. Yes, let me show you why. So when we want to move an object, so we want this guy to move, let's say like left and left again, we obviously need to recalculate in which cell it resides, because if it moves up, it's no longer in the same cell, so we need to remove it from that cell's list, and we need it added to the new cells list. Now, if we can calculate because we also want to check if it's still inside the same cell, we don't delete it, we don't insert it again. So we will be calculating the old cell X and the old cell Y, so checking if it's still within, let me show you, it's still within the same cell. So if it moves up here, it's still in the same cell, don't remove it, don't insert it, just return. Try it again, okay, still in the same cell, now it's in another cell. Once it's in another cell, we want to delete it from this bottom cell, this one, and we insert it into this top cell. So we will be storing an old cell X, this will be our previous movement, before our movement, and then a new cell X, this will be the new, so it will check, this is tough to explain without code. So it will show here is our new cell. If this is still the same cell as the previous cell, so if this thing moved up here, it's the same cell, we don't do anything. If it moved to the next cell, you will see the indices changed. So if that happened, we want to still use the old indices to delete it from that specific cell. Okay, let me just write the function, you will see why. So this is the collider I want to move. This is the amount we want to move. So we'll just, let's rename this to delta X and delta Y. Okay. So first off, get the old index. So this is old cell X. This is the first index of the array, in the array. And this is the current position before any movement. So as we previously done, we take the X and divide by the cell size. Again, we do this with the Y as well. Okay, let me just take my example here. Okay, before any movement takes place, when we call move, we calculate in which cell is this little block. We see it's in this cell, so we keep those indices. Now, what we do next is we calculate, if we do the movement, what will the new index be? So it will be the collider X plus delta X, our movement in X, divided by cell size. And again, same for Y. So we'll just make this Y. So now if this guy, we want to move it by like 10 or something, we want to move it 10 up, so it goes 10 up. Now we calculate the new indices of the cell, and since they are different, we want to delete it from this cell and we want to insert it into this cell. However, if it's down here and we move it 10 up, then calculation will show that it's in the same cell, and we don't do anything, we just return. Now after we actually want to move it, so it doesn't matter if it doesn't change cell, or if it does, we will move it regardless. Line.x and line.y move my data. And something else we want to check, if there's any error, if we're trying to move a collider outside the map bounds, we will get an index error. So just check, of course, if collider.x plus the delta x should not be greater than shouldn't be greater than number of cells in the x times the cell size. This is just a reverse of what we did in start, this operation. So you can of course store map width and map height in your game as static variables and just call it from there, or you can store it in here, but I'm just quickly doing this way. So first it should be smaller than or equal to, I think, yes. No, not equal to. Because if we have, this is our maximum bound, it's the top left corner, so plus the actual width of the cell of the collider should not be greater than this thing. It can be equal to, so delta x plus collider. Oh, we even reject here. This is public. Not even okay. We're gonna have to edit this to access width and height. So we want to get width to check if it is moving out of bounds. Okay, do not switch these guys around, it's both width. And for consistency's sake, we'll just call this width. And we will copy paste this and change it to height as well. Okay. Now we're checking if this little, let me just draw the point. So that if you get the x coordinate of a rectangle, you're actually getting this top left point. So we want to check if it's moving outside of the bounds. This is the maximum, this line is the max that it should go. So we want to check if this x coordinate plus the width of the block should be smaller than or equal to this x of the max. That's why we're accessing width and plussing that with that and checking for the actual thing. If we go to the left, let's say that this line is now the minimum, this is 0, we don't want to go into negative. Since we already have the dot in the top left corner, we can just check if that actual dot, that coordinate, is equal to or greater than 0. So we then don't need the width. This same principle will apply to the height. You will of course need to add the height if you want to check if it's greater than the max, but you of course don't need to do it if it's at the top because we have the y value. Okay, I hope that makes sense. Hello, I'm sorry, Is this better? Can you hear me, Christopher? Just tell me if you can hear me. Don't know if you're still here. Hi, it's a bit into the live stream to notice that the audio is not as great. I'll stop typing when I'm speaking. It's a bit of a train smash. But anyway, not that bad. We'll move on. Thank you, Christopher, for telling me. I don't know if you'd be returning to the stream, and if you're still here. Let's do this again. So moving forward. So now we're checking if the collider X is not smaller than the min value of the map. There you go, so that check. Now we'll be doing the same thing for Y. Hey Christopher, I hope that's you that's back. I hope you can hear me now. Okay. And let's check the same checks for Y, just use Y and height instead of width and X. So let's put it in. Okay, just refactor the X to Y. There we go. Now we're checking if it's outside of bounds or anything like that. Just checking if the audio is still working here. Sorry for the technical difficulties. Okay. I don't know why my keyboard should be louder. It kind of sucks. I'll use the membrane keyboard next. We can even fix that this stream. I'll be right back getting the membrane keyboard so you can hear my voice. Hello everyone, I hope that you can hear me now. We have switched keyboards and now hopefully it won't interfere with my beautiful voice. Unfortunately I can't do much now to, go back. Okay. Nothing we can do except continue. Hopefully the code will speak for itself, Okay. So now we'll be checking if the collider has changed cells or not. So we'll just check using these variables we calculated up here. So if the new cell X is equal to the old cell X, so the index of the cells remains constant, we do not want to do anything significant. We just want to return. So we'll just say, but we also need to make sure that the Y is the same, because if we only check the X, we aren't using the same cell. We are using different cells if the Y changes but the X remains constant. So also check Y. Old cell Y. And if this is true, just return. So now, if this is not true, we want to remove it from the current cell and we want to insert it into the new cell. So this is where our actual delete will use the previous index. That's why we're passing indices and not calculating it within the actual function. So else delete the collider in the old cell. So So that's always our y and x, and insert is into the new one. We don't have to pass the indices here. We will calculate them in this function. You can probably gain a little bit of performance by adding an insert function that's similar to this. Then you don't have to calculate the actual index twice. But we're just going to ignore that little performance boost for now and continue. Let me just, for record's sake, reply here. Okay. Okay, let's continue. Okay, so our move function is done, our delete and insert. Now we want to get to the last few functions. This will be the delete, the update function, and the draw and check surrounding functions. Do you even have comments here? Okay. So let's start with our update function. This is where we'll actually check the collisions every frame. So we'll just call the cells update, and we will check for the adjacent cells as well. Update, we won't be using game time, so don't need to pass in parameters. Okay, so we'll just loop through every cell inside the grid. We aren't using a for each loop because we will be using the update function, and we will need the actual indices for the adjacent cells. So just loop through every cell. And under the hood, the for each loop is probably like this. I hope I am correct, but I really think it is. So just for J as well, for Y and for X. Let me just check my audio again. Okay, audio seems correct. Now I'm a little bit paranoid of messing up the audio again. Okay, so we update the current cell. So check collisions in the current cell and reset the rectangles to white if they're not colliding. And we want to check the surroundings. So check surround. And we will pass in the current indices that we will use in the actual function. Okay, let's get to that. Okay, I'll use X and Y. So this is where we will actually check if it's somewhere like here and it's in this cell. You want to check if it's colliding here, is it colliding here, is it colliding here, is it colliding here. So we're just checking the adjacent cells. We can easily do this with a little for loop, actually two little for loops. So we will just check from int I equals -1. We will add this to the X and the Y. So I'll show you now what I mean. Sorry. And it should grow. So we know that if you have it in this cell, we want to go to this up cell. So to do that, we just -1 from the Y and the X indices. And if we want to go to the bottom one, we +1. Let's say we +1 to Y, we go to this cell. We +1 to X and Y, we go to this cell. We plus only 1 to X, plus only 1 to Y. So we'll cover all of these cells from going from -1 through to 1. Okay, but there's a caveat you have to notice with this approach. If your map, let's say this is your minimum. If you're at the top here, this is 0, 0 at the 0, 0 index, and you plus -1 to it, you're going to have an index error exception because you're going to a negative index. So we'll just check for that in the actual for loop. It's an easy little check. So we'll just say, just implement the y component first, and we'll get to that little check. So that's 1 and increment. Okay. We also want to make sure if we already are checking for collisions inside the current cell. So we're gonna ignore 0, 0 in this method because we're already checking it. So we're just gonna skip if I and j is equal to 0. So if I is equal to 0 and j is equal to 0. Sorry, we don't even need brackets because this is a one-liner. We just skip this out. So we'll continue. Otherwise, if that's not true, we'll check if I is greater than, if you plus the amount of, if you plus the current index to the current index, the 1 or minus 1 something, you check if it's greater than the maximum size. And we also want to check if it's equal to it, because remember, when you index into an array, we start counting at 0 and not at 1. So if we have 50 cells, the maximum cell will be 49. Okay. So now check for y. And check for, then for x, this is for the minimum. We first did the maximum. Also check the minimum for y. Our minimum, we just keep it to 0. You can change, of course you can change this minimum, but for simplicity's sake, again, we're just using 0. Skip that iteration. Else, if none of these are true, that means we have a valid index. We want to check if the current cell, any collider inside the current cell is colliding with another cell, the cell we calculated, the surrounding cell. So y plus j. There we go. Finally, we want to see our sprites, so we need to draw them, of course. So we'll just define a method here, sprite batch, injects mic again. Okay, that's fine. We will pass a reference to sprite batch. We use this reference everywhere, and now we will draw the actual cells, and collider, actually the colliders inside the cells. So our cell in cells, we just say cell draw, and we pass our reference to sprite batch. Lastly, for visualization's sake, we will just draw lines to indicate where the cells start and where they end. So we will just go, let's say I smaller than 800 at cell size, and draw a line there. This is the horizontal line. Yep, no, this is the vertical line. So it will go from the top of the screen down to the bottom. So draw it from 0, I, 0, so from the x coordinate up here, down to the end of the screen, and we will not be modifying anything here. We will just use the actual bounds of our default MonoGame bounds. Again, this is actually hard-coded. You don't really want to do this. You want to define this as static or something constant somewhere and use it everywhere. Okay, this is just for an error because I'm not calling drawline. What's the problem here? Okay, it's an ambiguous reference. It's including the wrong library. Is it still a problem? Doesn't exist. Okay, let's just import Microsoft XMA framework. There we go, colors defined now. I'll do this again, but for y. So we'll just, here's I again, because it's not a nested for loop, so it's being redefined. Go to the maximum of the screen and draw a line. This is the horizontal lines from 0 to the maximum. Okay, so that will be that coordinate, and we'll go from 800, we'll go to 800, and we'll start from the current coordinate. And we also want this one to be green. There you go. What's the problem? It's still including the previous thing I just removed. There we go. Okay, it's no longer including the wrong color. Okay. Now that is the entire grid class. Now we can move on to actually implementing and demonstrating the grid itself. So first off, we'll be writing a little function, a few functions that we will use to illustrate the shortcomings of the normal for loop how can I say this? For loop method, the nested for loops. So I'm just gonna copy and paste something quickly. This will be a simple FPS display class, and you can get, if you look into the description, you'll find a link to it. It's not mine, it is, how do I pronounce this guy's name? Let me just check. I think it's like, it's like willmotil. I hope I pronounced that correctly. You find it on the MonoGame community site. It's not mine. All credit to him, of course. But this is a quick way just to put it in here. We don't even want anything else. So this is not even, math is not included yet. So using, where is math even? In which namespace? It is in system. Okay. There's our little FPS counter that we will be using to see how many frames we have per second. Okay, let's create our little for loop that will go through our entire list and check if anything is colliding. So we'll define our list of RectColliders, and we'll just call this rects, initialize it of course, and now we want to create, we're just going to create random rectangles. So we'll just make a random, initialize it, get an instance of the random class. And let's make a little for loop. We'll make 500 of the rects. Check everything. Everything's okay. Okay. So we'll just create 500 rectangles. This will probably, you'll see this will still work, and we will still have a pretty high FPS. But when we move to like 1,000, or let's say like 5,000, you will see it doesn't really give us any. I think it doesn't even function if I remember correctly. So we'll just make a new collider that will insert into the list. Okay, for the 100th time, I'm going to say this again. Do not define hardcode your values in here. And today I'm going to listen to myself, and I'm just going to define it in here. So it's a public static int map width, and this is 800, and we have another one, map height, and this is 600. I'll be right back. Let's quickly do something. Okay, I'm back. So first, when we create an instance of this rectangle, we need to make sure it stays within the bounds of our screen. So that is 0 for the minimum, and our maximum is the map width. So this is the x of the new rectangle, and we want a y as well. This is 0 and map height and x. Okay, so we want this to be smaller than the cell size, so we'll just say 1 to like 5 to 18 is fine. And as well for this, the other one, 5 to 18. Remember, smaller than the cell size. I'll say that 10 times more, you know. Now we want to add this to our rect list. Okay. Oh, I think here we don't have a player. So let's just define our player. So he will be just a RectCollider player, new RectCollider. We're going to make him, let's put him at 10 by 10x 10y, and we will make him 20 by 20 size. So it's easy to see where he is. Add him as well to the, or her. Well, it's a block, so it doesn't have a gender, so it doesn't matter, him or her. So just add it to the list and proceed. Okay, so we want this player to be able to move. Since I'm going to demonstrate two examples, I'm going to have different functions for the update grid and update rects. We're currently just doing rects, so we're just going to add a simple player controller right now. So if we press S key down W, we want the player to move up. So we'll just say player, we need to make this a global variable. So just player. Okay. Otherwise we can't actually change the position of the player. We have to get the index. I want to, if we press W, we want to go up. MonoGame is inverted, so remember you need to minus from Y if you want to go up. If you want to go down, you have to plus to the Y position. Okay, just repeat this, because we're gonna be able to go up and down. So S is plus. There's something to be aware of, careful. If something is moving in the wrong direction, like in any project, you likely switched the two around. A is the X minus, and D is the X plus. Okay. Now we want to draw every, so we're going to define a little function here. It will be a private function because we don't need access to this outside the class. Draw rects. We won't be using game time, so don't worry about that. We'll just say, but wait. We will be using sprite batch. Don't forget about that. Okay. So for each var rect in rects, draw it. So rect.draw, and we use sprite batch. Now we'll be able to see all our rectangles. Just draw. Just call it from this. And we need sprite batch. So this will throw an error. I hope you can spot why, because this is important for MonoGame. Do not forget to call spritebatch.begin and spritebatch.end. At least you'll get an exception, so it will tell you. You won't go unnoticed. But if you're wondering why something's not working in the draw function, just make sure to check these. Okay, now we're drawing our rectangles and we want to update them. So we can always just call rex.update, but we will need to do that for every rectangle. I think we can actually use a for each loop here. For each var rect in our rects list update. I do apologize for any sound you might hear. It is my dog going ballistic. Okay, now we're gonna do the glorified method of going through every single thing. So that's O n squared time efficiency. So let's do this. Start at the first rectangle and go to the amount of rectangles we have in the array. And check if it is intersecting with every other one in the rects list. If I is equal to j, so we're at the same index. If I and j are at the same index, we don't want to check if it's colliding with itself. So let's skip. Else, we won't even put an else here because it won't, if it won't ever get past it if it's not true or false. If it's not false. So and then we checked if the one at I is intersecting the one at j. If that is true, we make them both red. Now you can probably already see a problem we have here. It's checking 1,000 times. As I said, I think in the PowerPoint it was 2,450. That's a bit of an issue. Let's test our code. Can we see? See, there's all our rectangles. I hope you can see this. Yes, you can. Okay. Let me just double check you can see this. Okay. So here's our player that's moving. You see if any of these are intersecting, they turn red. Now this is all well and good because we only have 500 rectangles. We can even display get a little bit of statistics here. So let's, because you see why we add this, let's see how many FPS we're getting. So using that simple Fps class we used from we'll just create an instance of it. It needs a font, so we will add a font now. Font file. How do you do that? I don't know if I ever showed this in a video. You just say .NET if you're on Linux. If you're on Windows, you can probably just double click on your content.mgcb file, this one. You can double click on that and it will add it and it will open the content editor. So if you're on Linux, you can just say .NET and what is it, mgcb editor. There we go. Okay, so we open our project to open this file. And we'll add a new item. We will call it font.sprite font. And it will not bold because we don't have Arial on Linux, or I have it installed on this machine. So we'll just change that. I think that is correct. Let's see. Yes, okay, we do support that font. So now in content, you'll load that font. Okay, I forgot to define font previously. So go do that now. So content.load sprite font, and we call it font. Isn't that creative? We'll just define it here, font. There we go. Okay. So we need to update the FPS class every frame, of course. So update game time, and we want to draw it as well. So we're just going to call it here. We're going to call it last, so it is rendered atop everything else. Draw FPS. Okay, current sprite batch, and the font we defined. You can think of any place you want this. I'll just put it at 700 X and 0. What color we will make this? We will just make it blue. There we go. Okay, what's the problem here? Cannot create a static instance. This is probably this is the wrong vector class. Not using the MonoGame vector. Gotta go back up here. What's your issue? What should you be importing? Vector 2. There we go. Okay. Let's see how many FPS we're getting. Probably won't be able to read it because there are thousands of objects behind. Okay, we can read it because it's not as many objects now. As you can see, the FPS is 60. That's not too bad. We can't see the elapsed time, so we'll just move it a little bit to the left. And just so we can actually see the FPS, we're going to fill a rectangle behind the FPS. So fill match dot, what is it, fill? Yeah, I won't pick it up yet because I haven't imported MonoGame extended. Okay, let's import MonoGame extended. Fill a rectangle, new rectangle F. Doesn't even have to be a rectangle F because we already have everything. It will be, let's say, 100 block, and we want it to be got a dot. Might probably work. Let's see. Can we read it properly now? Okay, let's just make the width. Elapsed time is too large, so we can just go here, math word round elapsed time, and we'll just run it to, and we'll make this a little bit larger, say 200. Okay, that's the wrong value. I changed the X. As you can see, everything is going well. I'll just change the X now, the width. And now I'll show you how fast this thing really becomes. Let's put 5,000 objects in. Now you see the issue. See how quickly it doesn't even want to render. Now that's a bit of a problem when you want the actual game. See how 5,000 objects in here, all colliding, and .NET's not responding. It's telling me to kill it for squid, you know. I mean, I can't even move the player. So let's see how many frames per second we're getting. We're just gonna have to wait. There we go, 2 frames per second. Now, isn't that great? I wonder if we can see how much CPU this is using. Let's see. It is using 8% of the CPU. That's quite a lot for just 5,000 objects that aren't moving or doing anything. It's just checking collisions. So how we will improve this? We'll just use the collision grid we just wrote for how many hours? 2 hours, almost 2 hours. Okay, Let me show you, compare it with that. Update rect. So we just move our code we use to update the rectangles into another part of the program. Move it here. Let's just fix the indenting. This code will obviously be available on GitHub. I'll check when I can make it available. Okay. Now since we aren't initializing rect anymore, we'll just move this also to another function. We'll just take this. We'll still be using random, so we'll use, okay, we'll just ignore that part I just said. Otherwise we have to pass it. I don't want to do that right now. I just want to demonstrate the grid. Okay. Now let's create a variable, a grid variable. Grid, and this is collision grid, and we want to initialize it, so it says collision grid dot initialize, right, equals new grid. What's our sizes? It's map width, map height. Okay, so initialize that part. Now we want to insert rectangles, so we can just quickly copy this code. Some of it is still applicable. We'll just not add to rex this time, we'll insert the collider into the grid, so grid.insert collision grid, insert collider. Okay, this is all fine still, we just need to insert player into the collision grid. Okay. Otherwise we're not gonna actually have a player. So collision grid dot insert, and that is the player. Okay, that's fine. Is there anything else we need? We need to update everything. So let's get to our update function. Change this a little bit. This will no longer be -1 and +1. It will still be, but we'll just call the grid.move collision grid.move. Which one do we want to move? We want to move the player. We have a reference to that. And this is, we want to move it one up. Just copy, because it's all the same, it's just changing values. So there should be 1, and this should be 0. No, -1. 1 and 0. And of course you want to call collision grid.update. And now lastly we want to draw everything in the collision grid, so we'll just say, let's comment this guy out because we won't be using that one right now. Collision grid.draw using a sprite. That should be all around good. This is worth, there we go, this is worth 5,000 rectangles. As you can see, 60 FPS. We can go back and see how much it's using here. You go and check, it's only using 2%, and that's for the same amount of rectangles. And just look at that. We can actually push this a little bit further. I think we can go quite a bit higher. It struggles at like 50,000, but I mean, are you going to use 50,000 particles? I mean, this is 10,000 particles, still 60 FPS, you know. And now we're getting to 7% CPU usage. Let's do some real stress testing here. 50,000. Ah, there's struggles. I mean, look at that. You can't even see the screen anymore. The 50,000 is a bit much. You can, of course, make this even more efficient, but you can already see it goes up to like 10,000, 20,000. Just for these few lines of code and a few assumptions. Let's just make this 500 to show that it actually works. Otherwise, we just get a red blob on the screen. There we go. You see, intersecting, weird intersecting there. Let's put this between, still intersecting. As you can see, if we're between cells, these green lines are the cells, we're still intersecting everything. So now you can take this and apply it to games, actual games. Of course, your objects might be moving, that will decrease the efficiency and make it handle less, as you will be inserting and deleting constantly. But I think that is all for today's stream. I hope you enjoyed this despite the issues with audio, and I hope this helps you to understand collision detection in MonoGame and in general games. This is applicable to any programming language, any framework, any Unity. I mean, you can even implement this in Unity, OpenGL, SDL, anything. This is the basics for everything. So I hope you enjoyed it. Enjoy your day.